So what if I told you the secret to absolutely crushing tree problems in coding interviews wasn't about memorizing hundreds of solutions? What if almost all of them, the vast, vast majority, are just slight variations of a few core patterns? Because once you see them, you really can't unsee them.
You know that feeling, right? That little pit in your stomach when a tree problem shows up on the whiteboard? You start thinking, oh man, there are a million different kinds of tree problems. How could I possibly be ready for all of them? Believe me, you are not alone. It's a classic interview hurdle for a reason.
But here's the thing. That's the big secret. It's not about memorizing solutions. It's about recognizing the underlying pattern. Once you really get a handle on just a handful of these, you'll be able to solve most of the tree questions they throw at you with a ton of confidence. So let's break down exactly what those patterns are.
And we have to start right at the beginning, with the absolute foundation of it all, the art of traversal. I mean, you can't solve a problem about a building if you don't know how to walk through its hallways, right? Same thing here. First, let's just make sure we're all on the same page. We're going to be talking almost exclusively about binary trees. Super simple concept. Each node can have a left child, a right child, both, or neither. That's it. But this simple structure, well, it's the playground for nearly everything that comes next.
So, how do we actually walk through this tree? Well, there are three main depth-first strategies. Think of it like reading a chapter in a book. Pre-order is like you read the chapter title first, then the left page, then the right page. In order is left page, title, right page, which, by the way, for a binary search tree gives you a perfectly sorted list. Pretty cool. And then there's post-order, left page, right page, and then the title. This one is perfect for when you have to do something with the children before you deal with the parent.
Now you've got two main ways to code these traversals. Recursion is usually the one that clicks first for people. It's clean, it's elegant, but it's got this hidden danger. If you get a really lopsided, skewed tree, you could actually blow the call stack. The iterative approach, where you manage a stack yourself, is way safer and gives you more control, even if the code doesn't look quite as, pretty.
The other major way to walk a tree is totally different. It's called breadth-first search, or level order traversal. Instead of going deep, you go wide. You visit every node on level 1, then every node on level 2, and so on. To do this, you're going to use a queue. This is your absolute go-to pattern for any problem that talks about levels or finding the shortest path from the root.
Okay, so we've got our traversal tools. Let's look at our first big family of patterns, path-based puzzles. These are all the questions that are about finding a route, counting routes, or summing up values along a specific path through the tree's branches.
It is so important to see that not all path sum problems are created equal. The simplest is a root to leaf sum. You basically just subtract from a target as you go down. Easy enough. But if the problem asks you to count all the downward paths that sum to a target, even ones that don't start at the root, that's a huge signal that you need to use a prefix sum hash map. And then there's the big one, finding the max path between any two nodes. That requires a really clever post-order trick, where you're calculating the maximum gain a node can offer upwards to its parent.
And this right here is the absolute key idea for that max path problem. A path can come up from the left subtree, bend at the current node, and connect with the path coming up from the right. Bam, that's a complete path. But, and this is the trick, when that node reports back up to its parent, it can only pass along the best single path, either the left gain or the right gain. It can't pass both. That's the whole game.
A really close cousin to that problem is finding the tree's diameter. It's just the longest path between any two nodes. But here's the classic mistake people make. They assume that path has to go through the root. Nope, it absolutely might not. The analogy of the longest hallway in the building is just perfect. It could be entirely within one wing, completely bypassing the main lobby.
All right, let's switch gears. We're going to move away from paths and start talking about patterns. They're all about the tree's overall architecture, its shape, its balance, and the relationships between all the different nodes.
Okay, this is one of my all-time favorite analogies because it just clicks. Finding the lowest common ancestor, or LCA, of two nodes is exactly like finding the first common manager for two employees on an org chart. You just trace their reporting lines up and up, and the very first manager they have in common, that's your LCA.
Another really important structural idea is balance. So what does it mean for a tree to be height balanced? It means that for every single node in the entire tree, the height of its left subtree and its right subtree can't differ by more than 1. It's a really strict rule that keeps the tree from getting all long and stringy like a linked list.
And why do we care so much about balance? Oh, it's everything. It's all about performance. A balanced tree guarantees that its height is roughly log of n.
That keeps your operation super fast and your recursive stack nice and small. An unbalanced tree, on the other hand, it can basically turn into a linked list, and all of a sudden your height is O of n, and all those awesome efficiency gains just vanish.
Okay, finally, let's take a quick peek into the Expert's Toolkit. These are a few of the more advanced patterns for those times when the standard approaches just aren't going to get the job done. So we're talking about things like rerouting DP, which is for problems like find the sum of distances from every single node to all others. There's a whole family of patterns just for binary search trees that take advantage of their sorted nature. Then you've got serialization and reconstruction, which is just a fancy way of saying turn this tree into a string to save it and then build it back later from that string.
That rerouting pattern is built on such a beautiful idea. Calculate once, adjust for all. It's this super clever trick where you do all the hard work just one time for some random root. Then, as you move the root to one of its neighbors, you don't recalculate everything from scratch. No way. You just make a small, constant time adjustment based on the info you already have. It's an incredible efficiency win. So we have covered a ton of ground here, but the whole point is to shift your mindset. Stop thinking about tackling individual, isolated problems. Start thinking about building a mental toolkit of these powerful, repeatable patterns.
And you want to know the best part? It is not an infinite list of things you have to memorize. It really all boils down to about 10. Yeah, that's it. Just 10 core patterns. You master these, and you really do have the keys to unlock the vast majority of tree problems you are ever going to see. So here it is. Here's your takeaway. The next time you see a tree problem, don't just dive in and start coding. Just stop for a second and run through this mental checklist. Ask yourself, is this really just about traversal? Is it a path puzzle? Is it a question about the tree's structure? Or is it something more advanced, like a BST problem? Just classifying the problem correctly is honestly half the battle.
Because at the end of the day, the real skill isn't about having a specific solution memorized. It's about looking at a brand new problem you've never seen before and having the confidence to say, okay, I see what's going on here. This is just a variation of the maximum path sum pattern. Or, you know what? This smells a lot like a level order traversal problem. That recognition, that's the whole game.
So there you have it. You have the map. The world of tree problems isn't some scary, endless forest anymore. It's more like a park, and it has clear, well-trodden trails. The only question left is, which one are you going to master first?